As you all know, the Perseverance rover successfully landed at Jezero Crater February 18, 2021 at 8:55 p.m. UTC using a similar daring landing technique to its sibling Curiosity. I am sure many of you stared at the stunning panoramas sent back to Earth, trying to match the rocks, hills, dunes, and cliffs with what we are able to see on the high-definition pictures from orbit we already have at our disposal. The exercise, though, is not as mundane as it seems. For instance, the Apollo astronauts had a lot of problems orienting themselves on the Moon. The atmosphere on Earth, the vegetation, and the distance of the horizon play a major role in helping us recognize our environment. How to match those interesting features from the ground with their counterparts on the map, and how to understand where the Perseverance rover is and where it is going, that's what we are going to learn in just a moment. Welcome everyone to the very first episode of Getting to Space, your new channel about space exploration. My name is Steve and I'm glad to present to you today's subject, getting to understand where we are on Mars as seen through the eyes of the Perseverance rover. And by that, I mean truly recognizing the landscape around us as if we were there, as opposed to just looking at the white dot on the map to orient ourselves. What you are seeing now is the first panorama from the rover. The land appears to be rather flat in the immediate proximity, which is always a good point for landing safety. When we zoom in, we can see rocks in the foreground, a big rock in the middle, and some hills or mountains in the distance. Then a cliff appears in the middle, and it grows gradually in height, as well as a mountain behind it. It's truly beautiful, but what is the scale of all that? It could be very close or very far, we don't know yet. Here is the map of the Jezero Crater, the white dot being the landing site. Upon zooming in, we are able to see different patches of terrain, flatland, rocky ground, and some dunes. As we get closer, we can notice this hill, 70 meters or 230 feet above the surrounding terrain. Going up north, there are more dunes, then a patch of flatland with a few cracks, followed by the delta of an ancient river about the same height as the lonely hill. Let's look again at the rover's panorama. By zooming in a little closer, we can definitely see a little cliff in the middle of the image. This is not an impassable wall though, as we can see a few smoother spots here and there. If we follow the edge, there is a headland high above the surrounding flat terrain. Perhaps we can match it precisely with the map. There it is, we definitely have a match here. All the smoother paths we saw are here too. We can precisely match every one of them with its counterpart on the map. We are now precisely oriented on Mars. But let's look at it a bit on the left or west, to this large opening in the cliff. Of course we can see it on the panorama, but now it's getting a little bit blurry, isn't it? Luckily, Perseverance has other camera lenses. With this high-definition view, we can get a much clearer image of the area. As a matter of fact, this smooth slope between the steeper sides has been identified by NASA as a path for Perseverance to reach the top of the delta. we now have our future waypoint in sight. Of course, I will not show you every feature in the 360-degree panorama and its matching equivalent on the map. That would make this video far too long. But you get the idea, and I encourage all of you to take a look at the pictures and at the map. The links are in the description. What features could you notify? Could you see the rim of the crater? Leave a comment below and let me know. The next thing I wanted to show you is this lonely rock or mound we saw at the beginning. It's easy to spot on the map, as it is almost due west of the rover. I've adjusted the colors to make it pop out of the surrounding plains. On top of it, we can see an interesting layering appearing. That's because this mound is in fact a part of the delta that remains alone, after what originally surrounded it was eroded away by the wind and maybe water. That's why scientists want to drive closer. If life ever appeared in Jezero Crater, it is very likely that it was in the delta region. In that case, the evidence is buried in rocks like this one. By making the different layers easily accessible, the erosion made the lonely mound a perfect place to look for past signs of life. We will now look at the possible routes available to us. But first, if you enjoyed the video so far, I would really appreciate if you could click the like button. That way YouTube will show this video to other people, and in turn it will help me make other episodes. Be sure to subscribe as well. Going on, this map shows a possible path for the rover from its landing point in white to the narrowed valleys on the top left. The yellow line was designed before the landing, based on the type of terrain, slopes and scientific interest. To get to its start, we cannot go in a straight line because of the rocky and sandy terrain in between. Two options are on the table. The northern blue line offers a safer, shorter path, 5 km or 3.1 miles, while the purple southern line, 6 km or 3.7 miles, offers more opportunity for science, such as the lonely mound we saw earlier. If the rover moves at the same pace as its sibling Curiosity, it would be at least 1.6 to 2 years for the blue or purple part alone. It's clearly not a race, it's an exploration. And that concludes our episode for today. Thank you for listening, and see you next time. Bye!